Hello everyone and welcome to another episode of Research Fails. So if you've seen any of the other videos in this playlist, you'll realize that I named the playlist Flat Earth Research Fails, and the other ones have tackled on claims that flat earthers and or moon landing deniers make that are clearly false. However, this one I have titled it Globe Earth Research Fail, more specifically something claimed by moon landing defenders. So you might ask, have I actually changed sides? Have I become a flat earther, or at the very least a moon landing denier? Of course not. No, that would be silly. However, this playlist has been about tackling claims that people make constantly without actually verifying it. And unfortunately, this is one made by people that defend the moon landings. And it's very clearly false, as I will show. Now, I want to say, one of the few valid points that flat earthers make is that a lot of people believe all these things without actually having proof. So yes, that's true. Most non-scientists don't have the understanding to see all the evidence for the heliocentric model. They just believe it, but the same way that most people will go to a doctor and trust what the doctor is saying without having a clear understanding of it, because we can't all be experts on everything. That's the case. That's why we have the peer review process, and that's why we have all different kinds of checks for each thing. So if you go to a doctor, you might not have the knowledge to say, okay, what he's telling me is correct, but we do know that doctors have to go through a rigorous process of education and then of getting their license, and if they screw up in any sort of way, they will probably lose their license. Now, of course, once you get politicians involved in all of this and everything, the system is not perfect, but it's generally good enough. So the same thing is for scientists of other things. Like, you don't have to learn about everything to know that most of the information out there is true. So now that's out of the way. If you don't really know about something, then when you're starting to say things in the internet, you should at least say, I might be wrong of this, or don't state it as decisively as most people do in the internet. But it's the internet, and people should already know to take everything with a grain of salt, including probably my own videos. So anyway, the claim is that I have seen many times that you can see the moon landing equipment with a decent telescope from your own backyard. I've seen this claim made many times, and this one actually gets called out a lot, unlike the other ones that I did a video on. And most of the time it's actually globe earthers themselves that call them out, because they're the ones that know the science. For flat earthers or moon landing deniers to call them out on this properly, they would have to know math, and we know that's contradictory. So usually they just say bullshit, or I don't believe you, but they don't state why. Well, I'm going to state why. So we have to talk about angular resolution. So yes, literally in this case, the case as to why we can't see the moon landing equipment with a decent telescope from our backyard is because of perspective and angular resolution. But I use these words correctly, not like the flat earthers. So what I'm showing here is what is called a point spread function, and it has to do with the fraction of light going through the optics of a telescope. So let's say you have a point light source like the one here in the middle. The smaller your aperture is, the more diffraction is going to create, and that creates an interference pattern in your optics. And so with a very large telescope, you might see a point source like the one in the center picture, but with smaller apertures, you will start to get these interference patterns that you see all around this. And this is a theoretical limit, like no amount of technology will get you over this limit, at least not with a single telescope. There's also interferometry, but that's something else. If you only have one telescope, no matter how good your optics, you're still going to get this at some point. And it's directly related to the diameter of your telescope. So now what we actually mean of angular resolution is this. It's basically the angular size at which you can distinguish two different point light sources. So this is measured in angles, because angular size, the field of view, which is given by the law of perspective. So the 2 points and at the top of in the image at the top are barely resolved. This is what's called like when these two like edges are barely touching. It's what's considered this angular size would be the angular resolution. If they get closer, you can see they start to blob up together, and here you can't even tell that it's 2 points instead of 1. So the actual equation for angular resolution is this. So this would be the angular size of the object in radians. It's important. Scientific notation, it will be in radians. Lambda is the wavelength of light, because yes, the resolution will depend also on the wavelength of light. This would be in meters, and the diameter of your aperture, like the diameter of your telescope, also in meters. So now, what would we need to resolve the objects on the moon? Now here, there's a difference between like this definition I have said of resolving something and actually being able to see it clearly. So this, I have taken the 10 meters is the largest object. This is the distance between the two opposing landing legs on the descent module, which would be the biggest object of them all. And I think it's a little bit less than 10 meters distance. So if we could just imagine that both of these, like the 4 landing legs, have a very, very bright light that would shine much brighter than the surface of the moon. To be able to resolve them from each other, so you need a resolution of 2.6 times 10 to the negative 8 radians. Now for flat earthers out there, this is not a negative number. It's a really small number, but still a positive number. And if we now plug this into for this equation and solve for the diameter, we would need a mirror of about 17.8 meters in diameter. Here's the problem. Currently, the biggest telescope that I could find, at least this was from, like the info was from 2014. I'm not aware of any other telescope having been built since then, but it would be the Gran Telescopio Canarias, 10.4 meters. And yes, you cannot resolve them. So yeah, here it's bunk. Also, I must point out that I used 380 nanometers for the wavelength of light, which is the limit of visible range. This is the violet wavelength. Usually here, like especially if you want a color image or something, you would probably want to use the middle ground, so it would be a bit of a larger wavelength, which increases your diameter. So even with pointing, just barely being able to resolve the two points furthest away from each other in the landing module, with the shortest wavelength, we're still falling up short by 7 meters. So yes, that's the biggest telescope, and I've seen people say like, yes, you can just get a decent telescope. I have a decent telescope. the telescope alone, like the optical tube, was around $850, if I remember correctly. I bought it ages ago, and it's 8 centimeters in diameter. So clearly not enough. I should just add something here really quick, that this is not actually the proper equation to get the angular size. Like this is, I'm basically dividing the size of the object by the distance to the object, and what this actually gives you is the tangent of the angular size. However, for really small angles, you can approximate the tangent as just the actual angle, as long as you use radians. That's important. So yeah, tangent of this number is going to give you something close to this number. So just, if you really want to be precise, you need to like do this division and then get the arctangent. Now, as I've said before, like this is calling out the moon landing defenders that make this claim. However, the moon landing deniers, instead of actually refuting this claim properly, tend to actually make similar mistakes. Actually, in this case, particularly the flat earthers, not the moon landing deniers. So there's a difference between being able to resolve 2 points and actually being able to see something. I am not stating that you cannot see stuff that is smaller than the angular resolution of a telescope. You can, and this is what's called point light sources. So whenever you see a star, that star is smaller than than the angular resolution of your eye. Speaking in angular size terms, obviously stars are really big, but they're also really far. The thing is, if we go back to this image, basically how cameras and your eyes work is that a photon hits a sensor, whether it is within your eye itself or in the camera, and that gets like interpreted by either the camera or your own brain. So the thing here is that, let's say you only have, let's ignore all these other pictures, you have this star in the middle, but your angular resolution limit would be something about this size. So what would mean is that light from this point is like hitting in all this area, that will be, and you would essentially see all of this area as white, but you would still see something. What this means with angular resolution is that if instead of just being this one star, you would have 10, 20 stars around here, you would all still see this as one big blob of light if you zoom in this much in. But no, like if something is bright enough, even if it is much smaller than your angular resolution, you will see it. All it takes for you to be able to see something is for enough light to reach your eye to be able to detect it. So now, saying this, in theory, if the landing module had a very bright light, even if it's just a small bulb, but if it's very powerful light, we would be able to see it when it's night on the moon, like on its side of the moon. But of course, there's absolutely no reason to put a giant light bulb on top of the LEM. It would have been silly. But yeah, for those flat earthers that say that when things are just too small that there's just no way to see it, that's not true. The amount of light also helps, which is why, I don't know, I think most flat earthers don't fly, but if you've noticed, when they're giving the safety measures in airplanes, they show the life vest and it has a very small light bulb on it, and that is to help people see you at night, like rescue. If you follow the flat earth logic that size alone determines whether you can see something or not, that little bulb would not help you be spotted because it's much smaller than yourself. Now, the other thing that I want to call out flat earthers on is that I see a lot of times this request of them to say, why doesn't NASA get one of the telescopes in geostationary orbit or on the moon or the Discovery and zoom in on people walking upside down? Now, I know there's spy satellites that can definitely resolve like people. I don't know. I know a lot of it is exaggerated, but I'm pretty sure one of them must exist. But these ones are close to the Earth, so and they are always looking straight down. So you can't really say, like, if you show a picture of someone, you can't really say, okay, they're at the bottom, in quotation marks, of the sphere. So presumably what they want is something that can see like the entire sphere of the Earth, like one whole hemisphere, or at least a big portion of it, and then zoom in to see someone walking upside down. Again, quotation marks. But then we arrive to the same problem. Let's take a tall guy, 2 meters. I got 35,000 kilometers, 35 million meters for the distance. This is geostationary orbit. The angular size of said tall guy would be 5.7 times 10 to the negative 8 radians. Again, positive number, but really small. Now, to be able to resolve the head from the feet, again, this would not give you like the image of a person in detail, just the head and the feet would be more or less distinguishable from each other. You would need a mirror of 8.1 meters diameter. The biggest telescope in existence today in space is the Herschel Space Telescope with 3.5 meters diameter. So again, we fall short. Then there's another problem. They're actually asking, see the entire Earth, then zoom in. Space telescopes have no reason of having such a deep zooming ability, because they're always seeing stuff at a more or less constant distance, as in pretty much at infinity. Like, either they're observing the Earth and they're set up to like the field of view that will get everything they want to get from the Earth, such as Imawari, they want to image the entire Earth. What more specific like detailed observation satellites are closer and they're set to image a small portion of it. Adding such a deep zoom increases the complexity of the mechanism, and it increases the likelihood of it failing. If it fails, you can't repair it. We don't have something to send a repair mission for a satellite that it's in geostationary orbit at the moment. So it's a really silly request. So yeah, that's the reason why if you ever see someone claim that they have seen the equipment left on the moon from their own backyard, you can just call them out on it. Now, as you know and I've stated, I know the moon landings happened. There's more than enough proof for them. This is just not one of them. And it does nothing for the cause to be stating these kind of things. Now, yes, it's the internet. You will find all sort of wrong claims. Just so you know, if you see this, it's false. Doesn't diminish the accomplishment that these people made. And there's tons of other proofs that you can look for. And flat earthers and moon landing deniers still do not know what they're talking about. Proof of this is that they could not even refute this with the right reasons, even though it's two of their favorite words, perspective and angular resolution. They like to use them, they never know what it means. Okay, so that's all from me. Thank you for watching, and I'll see you next time.